And this is important. I think there's a lot of thinking that what SPLUNK is about is log data. We have a lot of capabilities to capture a lot of IT data sources that you don't think of as logs because they're not log files or syslog or Windows events. And one of those capabilities is that we can baseline and monitor the Windows registry and Active Directory. And then that enables you to start to correlate information around people's user accounts or registry configuration with your logs and other IT data. We also are increasingly used for our capabilities to capture configuration files and changes. So PCI in particular, there are new requirements to do file integrity monitoring, but it's also very helpful for a lot of use cases around operational troubleshooting to be able to know what was the configuration at that time next. And we also can be used to poll for system metrics, so you can kind of be your time machine for what a system was doing at any given time. So you can use us to poll for system metrics like perf on Windows, getting CPU and memory and other stats off of commands on Unix, like top and IO stats. And those are really special cases of a very, very flexible capability we call scripted inputs that allows you to connect to any logging API or call any sort of status command as a script and index the output. And people have used that for capturing things like JMX, for even capturing actual messages from message queues, for talking to SQL data stores, which are increasingly the repository for logs and other IT data. And then once data is indexed, the search and navigation capability allows you to both search live data and historical data. So I do want to emphasize this live data point, which is SPLUNK is absolutely unique. Even though we've been copying this notion in the last 5 years of indexing this kind of data, everybody else is using document search technologies to go back and build an index in batch over this data, and that doesn't give you that up-to-the-second search capability, and it doesn't support our real-time search capabilities where you can essentially be watching events as they come in. And the search is very flexible, so you can if you know how to use Google, you can get started with SPLUNK. It's very flexible, free-form search. And we introduced this notion of point-and-click navigation. I would say that was a transformation. I've been working on log data projects at that point for close to 10 years. And when I first tried SPLUNK in 2005, and when I first came on board, just being able to have your hands on the data and point and click and navigate that is something that has been transformational for people using SPLUNK. It's amazing how many Tier 1 teams who supposedly don't know what's in their logs have learned how to use their logs to do their jobs just by being able to explore the data through SPLUNK. Now, this capability of discovering and adding knowledge, this is probably one of the most misunderstood capabilities of SPLUNK, so I'll put a minute on it. So, knowledge for us is going beyond this sort of unstructured, free-form search into being able to have structure on the data, but have that structure be applied at search time and be something that can be changed at any time by users or added at any time by users. And SPLUNK has capabilities where it tries to discover that structure for you. So if you feed it very nicely formatted data in name-value pairs, you don't have to do anything more. You don't have to do anything more in order to actually start looking at the data in a structured way. It's going to do that for you. But if you feed it messy, variable, unplanned logging that's legacy logging, you can, as an end user, while searching the data, you can go and say, okay, well, that third field in, I want to call that source IP so I can start to do structured search on source IP. And this is how SPLUNK has normalization capabilities, but we normalize on the fly. And there's aliasing and tagging and lookups that extend identifying structure in the data itself into the ability to do any kind of normalization. But most importantly, you're not limited to what you planned up front, because the knowledge is applied at search time. So, monitoring and alerting, this is where, based on search, you can schedule any search to run on an interval and proactively monitor. And the search language, once you have the structure on your data, you can start to go beyond the free-form Boolean search where you're just doing simple keyword matching and simple and or not logic. And our extended search language, which I will show you some of, I'm sure, our extended search language lets you do powerful correlations with the data, and then embed those in searches that you set up for monitoring. So you have all the capabilities of a rules engine, but it's integrated into the same search-based language that's very flexible and consistent across all the capabilities. And then you can set your conditions for notification. Some people even use Splunk to trigger actions in their environment. You may get your notifications directly from Splunk via RSS or email or SNMP. And you may also use that capability to go send events to Remedy or some other kind of ITSM or ticketing system. So another thing that's unlocked by being able to put that structure on this unstructured data at search time and the capabilities of the search language is reporting and analytics. So those same powerful commands let you start doing correlation for your monitoring, let you start to do advanced statistics and analytics on the data. And then we have capabilities in the user interface to click your way to these more structured reports and set up charting and make nice reports. And but again, you're not limited to what's in the pre-made schema. And then you can schedule and distribute reports via RSS or PDF. So with these capabilities, what customers ultimately end up doing is they go beyond sort of ad hoc reporting, and they set up dashboards and views that are suitable to every role in the organization. So the sort of naked search box that Splunk is known for is something that power users, maybe your sort of tier 2, tier 3 in your operations teams, your development teams, your security analysts, they want to just, have active data, and they'll use that sort of default search interface. But you can start to create structured search form type views, shown on the left for more of your tier 1. So if you have routine calls and there's a complicated search behind the scenes that needs to get run every time someone calls and asks if this transaction is slow, you can simplify those views for your tier 1 teams. And then on the other end, you can create very powerful and rich dashboards that are suitable to executive management within operations, to auditors, and even increasingly to marketing and business analysts and other executives and even business owners. So the most mature Splunk deployments really look like this in terms of the user base. And over on the left is Steve's dog. So he claims that we created views for his dog, but it's not. Anyway, so behind the scenes, and we'll get much more into this in the afternoon session, but behind the scenes, Splunk scales. Splunk scales horizontally by being able to add as many indexers as you want and do distributed search, and most importantly, via MapReduce, distributed analytics. So you're not doing all of your final processing on one server. We distribute the load of running statistics and analytics and running your correlations across as many machines as you need in order to deal with terabytes of data per day. And we have increasing numbers of Splunk customers that are hitting those terabytes per day on a single logical system across a distributed set of servers. And then we also, down the bottom, provide what we think of as this data fabric capability, where our Splunk can be deployed as forwarders so that we can gather your data from across thousands of physical servers, and we're starting to see increasingly environments of tens of thousands of endpoints or tens of thousands of VMs in a virtualized environment. And really, there's nothing else like it in terms of being able to collect all of this data and then get it in real time to a central system for searching.